A very good morning, boys, teachers. Welcome to the next class of organic chemistry. Today we are going to finish the functional groups. First three we have done, that is hydrocarbons with the carbon to carbon single bond, carbon to carbon double bond, and carbon to carbon triple bond. Alkanes, here in your portion, that is aldehydes, carboxylic acid, and alcohols. Before we can start the class, the important points remaining the same, children. If you have any question, please do not type in the chat window. Please let me know your question. You just raise your hand. I'll take your question after the explanation, which is being that very time it's being done in the class. So it is much easier to solve your questions then and there. So if you have any question, you can ask me. One more announcement is there. Today you have your inter-house quiz selection. So at sharp 11:45 in the next class towards the end, you'll be given a link. You have to use the link and you have to solve the paper which is being given for the selection. The best students will be selected for the inter-house quiz competition. Okay, all the very best for that competition. Last class we had done how to identify and how we can see the places which are being changed of the function group. In all, you have 6 function groups as per the reduced portion, children. First is carbon to carbon single bond, that is being termed as alkanes. Right, carbon double bond, it was termed as alkenes. And then carbon to carbon triple bond, this is called as alkynes. These two are, this one is saturated hydrocarbon. It is being meant with the help of carbon to carbon single bond. There is no addition. There is no scope of addition. So that is saturated. But there is a scope of addition with double and triple bond. That is why these are called as unsaturated hydrocarbons. Now, when we talk about functional group, is there anyone who can tell me what exactly, now what is being given on the screen, that is it, but can you tell me what exactly we talk about? Why do we need functional group in organic chemistry? Anyone who wants to try? What do you mean by functional group? Okay. Yes, Saket?
Functional groups are a particular kind of uh, group of elements that have that act as that act as a bond for the carbon, and therefore some special types of carbon compounds are formed.
Okay. Saket, I really did not get what exactly you wanted to say, but can you see there are two terms in this functional group? Functional means what? How it can be? Yes, Naman?
Ma'am, they determine the properties of many organic compounds.
They determine the, very good, they determine the properties of any organic compound because all the organic compounds are made with the help of carbon atom. How it is being arranged, in what way it is being arranged to carbon to carbon, carbon to other substances. This decides the chemical properties of any organic compound. The same group is being classified because of the groups are being done, and this group we are talking about like homologous group, where they are going to they are going to have the same functional homologous. So they have the series of the same type. Whether we talk about alkanes means n is equals to 1 to n is equals to 100, n is equals to 1000. The functional formula remains the same, that is CnH2n plus 2. The same way, here the group is not the normal group. It is going to have the entire set of series of the compounds that belong to same group. And functional means what chemical properties is in common with that type of group. It is called as functional group. So if you are going to talk about alkanes, they have a set types of properties. Because they are saturated ones, they will never show addition reaction. They are always going to show substitution reaction. One is going to take the place of another one. But as you can see, alkenes and alkynes, both are having unsaturation. Double bond will change to single bond. Triple bond will change to first double bond. And then two steps it is going to change to single bond. There is still unsaturation after changing from single bond, double bond, triple bond to double bond. So this is the way when you're going to talk about the types of chemical reactions with one group. This is called as functional group. So we have done first three functional groups, alkanes, alkenes, and alkynes. Today we are going to start with alcohols. Children, if you remember, in acid, bases, and salts, we have done the chapter in that identification of substances being done as per the presence of any cation or anion that indicates the substance is acidic in nature, or when it is being added in the aqueous solution, it is being added to water, it forms hydronium ion H3O, hydronium ion, right? The same way, just opposite to acids were bases, OH minus ions, right? If you remember, OH minus ions are being the identification, or they are going to indicate the substance is basic in nature. In organic compounds, when we are going to have presence of OH minus ion or OH radical being present here, this identifies the substance is alcohol. The substance is alcohol. So that is what the difference is there in organic and inorganic compounds. In organic compounds, diagonal group for today, that is alcohol, it is OH ion which is being present, or OH radical which is being present, which shows difference in their chemical properties. So that is called as alcohols. There are many functional groups we are going to discuss. Carboxylic acid, aldehydes is the main group. And then we are going to have the substitutes, or their like when hydrogen is being substituted, that we'll talk about that in the further slides. When we talk about alcohols, children, as we have done in alkanes, CH4, one carbon atom, it was meth. And because it belongs to alkane, the end part was ane. Whenever we talk about these substances, when they have OH minus ion or OH radical being present here in for the identification of organic compounds, excuse me, when we talk about the nomenclature remains the same. In organic compounds, whenever we have to name a substance, the root name remains the same. Root name will be classified or given as how many carbon atoms are present. As you can see, it is one carbon atom. For one, we always use meth. Okay. And if it was a normal alkane, it was methane. Right, children? But how to name these substances, alcohols, if the presence of OH minus ion or OH radical is being present in any organic compound, it is called as alcohols. And if it is alcohol, the naming will be different. Right? So how it is going to be named? In place of whatever alkane was there, we are going to remove that part, the last part, and we are going to use OL. Alcohols, the name ends with OL. We are going to have the suffix here as OL. In place of E, which is being taken, that is being cancelled, and we are going to add here, this will be removed, and we are going to add OL. Like in place of, if it was CH4, it was methane. In place of one carbon hydrogen atom here, they are going to add with one OH ion here or radical. This becomes methanol. In place of methane, E will be removed, and in place of E, OL will be added to show it is not a normal methane. Definitely carbon to carbon, there is a single bond present. So it could have been methane, but because of replacement of one hydrogen with the help of OH radical, it becomes alcohol. So the name will end with OL. Now, what will be the naming? Methanol. Okay, or in the common terms, it will be methyl alcohol, ethyl alcohol. Meth means one carbon atom, so methyl alcohol. If two carbon atoms are there, ethyl alcohol. Three carbon atoms are there. Accordingly, the name will be changing as a common name. And if you're talking about the IUPAC naming, the naming will be done the same way as if it was an alkane. Write the name, remove E part, add OL to fix it, and you get the alcohol's name. Once again, in organic chemistry, when we talk about functional group, that will tell you about the group of elements or the group of compounds actually, which are going to have the same chemical properties. That refers to a group. And here we are talking about alcohols. To identify As we have done in alkanes, alkynes, carbon to carbon single bond indicates it is alkane. The same way, presence of OH minus or OH radical being present in alcohols, that indicates that this particular compound, that entire series we are talking about, is of alcohols. As it is organic compound, name will be given as per the number of carbon atoms present. As I told you for the first 5 elements, the same way, meth, eth, prop, but, pent. We are going to have first 5 members of all the types of compounds. Okay. So let's like first one, meth, CH3, and OH is present. The name will end with OL. So the name of this alcohol, which has 1 carbon atom, will be methanol, right? The second one, you can see it is C2H5. Is there anyone who can tell me what is CH3, what is C2H5, what is C3H7? Yesterday we have discussed about. Yes, Dhruv?
Ma'am, CH3 is methyl, C2H5
Very
is
good.
ethyl, and C3H7 is propyl. Ma'am, these are
I'm
the
so
alkyl
proud.
groups.
Very good, Dhruv. This is what I'm going systematically and very slow to make you understand. Children, whenever we have to identify any alkane, all the 4 valencies of carbon are being satisfied. But whenever just 1 hydrogen is being removed, now it is ready to pair up. It is going to pair up, and here in the case of alcohols, it is going to pair up with oxygen. As you know, children, when it is being given as the branch structure, you cannot write even OH, children. OH also together can never be written, because you know valency of oxygen is 2, hydrogen is 1. So how are you going to show? Carbon with 3 sides with hydrogen. I'm talking about methyl alcohol. Okay, children. So there are 3. Then this, when 1 valency is being less, and let's satisfy that it is free for the bonding. And here we are going to have first connection of oxygen. Oxygen has 2 bonds, one with the help of 1 carbon atom, and second bond will be done with the help of hydrogen atom. This is a way to show the branch structure of any substance. What happens? You remember about hydrogen and carbon. But once functional group also to be attached, this also to be shown with the help of single bond, double bond, wheresoever it is present. Okay, children? So this is the way when we are going to talk about any alcohol. Identification, presence of OH ion or radical. Number of carbon atoms will decide the root name, and the end part will be OL, alcohols, because the name ends with OL the same way, right? So methanol, ethanol, propanol, butanol, and pentanol. Yes, Dhruv, you can ask the question, child.
Ma'am, how do we write the condensed structural formula of methanol?
Methanol, this is the condensed structure, CH3OH. This is a condensed formula, and this is the branch formula.
Okay, ma'am.
When we show all child, it is called as a condensed formula. Right? Understood, children?
Ma'am, your
So
voice
I'm
was
giving you
breaking.
2 minutes. Okay, it is for everyone. Teachers, please tell me if there's any problem.
Ma'am, in between there is a bit of a lag, but I think that's due to the connectivity.
Okay. Now, can you hear me properly, ma'am?
Yes, now you're clear.
Thank you, ma'am. So children, do you want me to repeat that part? Okay. Just give you one more. I just tell you the thing. Nomenclature. Nomenclature is naming of the compounds, and we are talking about alcohols, children. How to identify? As I am going to have, say, we are having a debate competition, and there are many participants. And how to identify which is the group which is going to represent Bishop's Camp, which is going to represent. So we can see the tie and the badges which are being provided, and we can easily identify. So in organic compounds, all the substances have carbon. How to differentiate? With the help of functional group. For alcohols, the functional group is OH. single bond O, single bond H. Here also it is free to have one bond being formed, and methyl group also is free to form one bond, and that is why they are going to join together. Here this R represents the alkyl group. Okay, how to name them? We write the name of that that whatever it is, like if it is one carbon atom, we are going to write the alkane like methane, and E is being represented here is being removed, and we are going to add OL like methanol, ethanol, propanol, butanol, and pentanol. If I say pentanol means it has got 5 carbon atoms. Suppose I'm going to talk right now pentanol, meth, eth, prop, but, pent. Pentanol. If it is being given pentanol 1, that means we are going to have this carbon atom that is in the terminal position, whether it's organic chemistry, we can start from here also and here also. Both are same, equally correct. So if it is being given pentanol 1, so it will be H. So this carbon has got 2 valencies already being satisfied. 1, 2. This 2 are being done. 1, 2. This 1, 2, 3. Just keep hydrogen everywhere. Right? This is the way I told you how to draw the structure, branch structures of any substance. Okay. Now what is this? Carbon 1, 2, 3, 4, 5. C5. Hydrogen. 1. This is functional group. This hydrogen will not be taken as separate hydrogen. Here OH is a functional group. This will be taken as OH. Hydrogen will not be counted separately. That you have to keep in mind. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. C5H11OH. One hydrogen is being removed and it is being added with OH or radical alcohol. I'm giving you 2 minutes. Write the structures for first 5 compounds of alcohols. First 3 are being displayed right now and next 2 in the next slide. So just 2 minutes I'll give you. Everyone, children, it looks like you have understood, but once you're going to draw, you won't be able to draw. Just believe me, organic chemistry, if you practice the structure for 5 times, then there is a chance that you can draw it. This is a bit different from normal chemistry. So please practice it. And this is the basic part. Now, this is the original part of chemistry which is being asked in your board exam. So you have to practice this very well. Practice it properly and just get the hang of it, how to go about it. So first 3 members are being given. Everyone will write the structure, how to name it you're going to write, and you'll draw all 5 structures. Out of 2 minutes, 1 minute is almost over. Then I'll go to the next slide where we have next 2 members. Anyone has any question, please ask me. Yes, Taman, please ask.
Ma'am, do we have to show the bond between O and H? Because
yes, that is what I'm saying. It is very important in the board exam. What happens? You take it like if it is carboxylic acid, you write COH. No, we have to write. If it is being given for alcohols, it is not like this. You have to show C single bond O, single bond H. This is very important. You draw everything and see in the branch structure. Did I write anywhere OH? Single bond O, single bond H, single bond O, single bond H. This is the proper branch structure of any substance. So branching has to be done, bonds to be shown, each and every bond to be shown. Okay, Naman? Good question. Anyone else? No other question? Now, these are the next part when you're going to talk about next structures can be done. Now, children, as you can see, for when we have 3 carbon atoms, so we have 2 terminal positions and 1 middle position. If OH is present on the first position, it is called as propane 1-ol. Whenever numbers are there being differentiated with the writing part, we put a dash. That is I'm telling you one by one everything. Once we'll start with IUPAC naming, this same thing will be told to you. So just try to start learning small things right now itself. Whenever we write more than one number, numbers are being differentiated with the help of comma. That is always there. If I'm going to write a number specifying the place or the carbon atom on which functional group is being present, and before and after writing part is there, we have alphabets. Then there's a dash being used in between the numbers. Okay, so it is propane dash 1 dash all. It specifies that there is all means alcohol group which is present on the first carbon atom. Children, it can be here or it can be here also. If it is here, this becomes carbon 1. And if it is that, like as per the structure we've been given here, if it is being on the next side, it has to be this carbon atom which is being numbered as 1. Okay, so propane 1 all. Now there are two positions. As you can see, the middle carbon atom, which will be always number 2. Whether we start from here 1, 2, 3, or we start from 1, 2, and 3. This will be always 2. So the least number is this only. So it will be propane 2 all, because this is number and before and after are the alphabets. So we have to write like this. In the next structure, as you can see, there are 4 carbon atoms, children. So there are 4. This and this always will be same. But this will be second from this side and this will be second from this side. So here also, in spite of having one extra carbon atom, the position will be same, whether it is meth, eth, prop, bute. Now it is bute, not 1. It is having 4 carbon atoms. So for 4 carbon atoms, it will be. Is there anyone who can help me out? I'm there to help you. First, yes, Naman. What name I'm going to give? There are 4 carbon atoms.
Bute.
What is the spelling?
Bute.
B-U-T. Okay. Okay. Now, as it has got 4 carbon atoms.
Single bond. So, N.
It is N and E will be removed. Right, child?
Yes, ma'am. OH group. So, all. OL.
How will write?
Butanol.
Butane. And which carbon atom hydrogen OH group is present? 1, 2, because we'll number it. Huh?
1.
1 and
all.
Right? So it will be butane 1 all. What about this carbon? Saket, you can answer this question. Thank you, Naman. Perfect answer. Saket, you can answer this question. If I'm going to have 1, 2, 3, 4 carbon atoms.
Yes, ma'am. So bute 2 whole.
Butane.
Bute and 2 all.
1, 2, 3, 4. Butane 2.
All.
Is it correct? Or we have to write like this. Butane dash 2 dash all. Which is correct? Dash is correct or comma is correct?
Dash.
Huh?
Dash, ma'am.
Dash. Always remember, this is a small thing which you're going to learn stepwise, and when we are going to do in the nomenclature, these blunders should never be done. Whenever we are going to differentiate 2 numbers, it should be always with comma. Numbers with writing part with alphabets, that has to be differentiated, or they have to discriminate. We are going to use dash. Very good. So now, as you can see, children, this can be the chain formula. We are going to reduce the number of carbon atoms in the longest chain. It can be 1, 2, 3 or 1, 2, 3. On the second carbon atom, we have got CH3, which is the lowest alkyl group. Methyl group also is present. Now how to say? Is there anyone? If I want to name this substance, this is the condensed formula, semi-condensed formula, and this is the branch structure. Okay, Arya, a new name.
Yes, ma'am. 2-methyl
how,
propane.
first of all, what is the first step, child? If I'm going to specify 1, 2, how to know? First of all, we have to do the numbering. Yes?
Ma'am.
Okay. So numbering will start from?
Ma'am, right to left.
Right to left. Why right to left? Because OH is present on the extreme right hand side, and we have to give the preference to the functional group. 1, 2, and 3. Is there any other way of numbering the same compound, child?
Ma'am, no, ma'am, because the OH is on the right side, that's why we'll number
No, we
it
can
this way.
start from here, but there is another way to fulfill that. Is there? Child, just
No.
pay attention. If I'm going to have the longest chain of three number of carbon atoms, it can be 1, 2, 3 like this in the straight line, or you can have 1, 2, and 3. Position of alkyl group, if you have 1, 2, 3, it will be on the second position here also. And if you're going to have 1, 2, 3, this becomes the alkyl group and it will be on the second carbon atom. So the name remains the same. So it is all your choice. You can write in the straight line or you can go this way also. But it will have the same arrangement on the second carbon atom. It will have the alkyl group. If you are going to change that chain 1, 2, and 3, this becomes the alkyl group for this particular branching and on the second carbon atom. Right, child? And if you're going to take branching like the straight chain or the longest chain like 1, 2, and 3, on this carbon atom, again, it is going to, this becomes the alkyl group on the second carbon atom. Now, please help me out in the naming of the substance, child.
Ma'am, since the methyl is at second position, that's why 2-methyl, and the longest carbon chain is of 3 carbon, that's for propane.
So met at prop, yeah.
2-methyl, prop, and 1-all, because the alcohol group is at the first position.
You can write propane 1-all also or prop 1-all also. Both are correct. Okay?
Yes, ma'am.
Correct. Very good. So anyone has any question regarding this? Now we have got one more variation here. In place of OH group being present on the terminal position, it has shifted to the middle. Now this carbon becomes more responsible. It has got not only one alkyl group, but also one the main functional group of the compound, that is alcohol. So how to name this? Just specifying the number on which this carbon atom, this functional group is present. So children, it is very, very essential whenever we talk about any functional group, we have to specify which carbon atom it is being present on. So here, because it is going to change the terminal from the terminal position to the middle position, the name will simply change to 2-methyl propane 2-all. Because it is not on the first carbon atom, it is on the second carbon atom now, as you can see here. So it will be 2-all. So specifying the position of the functional group is very, very essential. Now, as a part of when we talk about alcohols, we have finished the nomenclature of first 5 elements, first five compounds that are there in your portion. Anyone has to ask anything, you can ask me. Or if you have not written, write all the formulas and write in the condensed formula as well as the branch structure of the same compounds. Meanwhile, I can take the questions if at all you have any. Yes, Anuj.
Ma'am, when do we say dimethyl propane 1-on?
Sorry,
When will it become dimethyl?
dimethyl.
Yes.
Okay. How many carbon atoms are there? 1, 2, 3, 4. Okay. With 4 carbon atoms, it is not possible because then becomes a, if it is like, suppose I want this to be as 2-methyl. Dimethyl will be 1 and 2 on the same carbon atom, but this becomes the longest chain. For this, it needs at least 5 carbon atoms, child.
Yes, ma'am.
Okay. So it will be like, I'll show you. You want dimethyl? I'll show you dimethyl. This will be dimethyl, and because we are talking about alcohols, so it will be like this. Okay, wait. I'll just make another structure so that it is much easier for you to understand. Just give me 1 minute, huh? You want dimethyl? We'll show that structure. Now we have got this carbon atom as dimethyl. Dimethyl means from the same carbon atom, 2 methyl groups are being attached, right? So 1, 2, and 3, this will be hydrogen. This also will be hydrogen. This will have more carbon atom here as well as here. This is alcohol, so 1 alcohol will be here. This carbon has satisfied 2 valencies, 2 more to be done. This carbon has done all 4 valencies. This carbon also all 4 valencies. This carbon 1 only. So 1, 2, 3. When we talk about this type of structure at all the terminal positions, it will be having hydrogen, children. To make it less complex, I'm not writing it, but you should know it. Okay. Now, when we talk about naming here, we are going to have longest chain either 1, 2, 3 like this, or we can have 1, 2, 3 like this, or 1, 2, 3 like this. Longest chain will be of 3 carbon atoms. Okay, so meth, eth, prop. Prop will be the root word. Okay, come what may, if you're taking as 1, 2, 3 here. 1, 2, 3 here. Actually, it has to be 1, 2, 3 here because the function group is here. So it has to be 1, 2, 3. Okay. Now on the second carbon atom, we have got 2 methyl groups. Because we have got 2 methyl groups, children, we have to specify the number of each methyl group. Okay. It is, what is Anuj? Can you unmute yourself, child?
Oh, yes, ma'am.
Because 2 methyl groups are there and both are on the second carbon atom, right, child? So we have to specify both 2, 2. 2, 2 for each methyl group. 2, 2.
Yes.
Then because after number we are going to write a dash. Then we'll write dimethyl. Then meth, eth, prop. Propane, 1, all. Did you get it? How we can get dimethyl here? But di
Ma'am,
means
why
2
do we have
methyl
to
groups
write
are there.
1
So
after the comma?
sorry.
After, like, why can't we just write 2 dimethyl?
2 dash.
Yes.
Child, 2 numbers right now I'm telling you as a basic rule. 2 numbers when we are going to differentiate, we are going to write 2 numbers, position of 2 carbon atoms. What we write? We write 2 colors, red, comma, yellow. What do we write? Red dash yellow. If I'm going to talk about 2 colors. When 2 things of the same kind, we differentiate with the help of comma. When 2 numbers are there, we put a comma. When we write 2 numbers, it is always with the comma we are going to differentiate. Right, child?
Yes, ma'am. So it will be
Understood?
2 comma. Yes.
Got it? First thing. Second thing, when you talk about when we finish numbering and we have to write the writing part like alphabets, it will always start with the dash. Like this. And then you write dimethyl, meth, eth, prop, propane, 2 all or 1 all because it was 1 all. Here there is no possibility of 2 all because this carbon already has satisfied all the valencies with the help of carbon atoms. So it has to be 1 all. Whether it is present this side or that side, it is the terminal position. So it will be propane 1 all. Okay, Anuj, I hope it is clear now.
Yes, ma'am.
In between, I could see 1 or 2 hands were being raised. It was to answer the question. Then it's fine. But if you have a question, you can ask me. Otherwise, I'd like to move on to the next group. Children, we have given a lot of time to this group. But I hope now you've understood when we have a different group leaving carbon to carbon arrangement. Next group is aldehyde groups. As I know, we got to know about all the groups here, like functional groups. This group is being represented with the help of CHO. The arrangement is C, double bond O, single bond H. Out of 4 bonds of carbon, 2 are being satisfied with oxygen, 1 being satisfied with hydrogen, and 1 group is still left. 1 bond is still left for the bonding. Here it can be done with R. You must have seen in the alcohols also it was R, and here aldehydes also it is R. R is alkyl group. But the thing is, when we talk about any functional group, that itself has its own carbon. This R can be H also, right? As in the case of alcohols, it was single bond O, single bond H. It does not have any carbon atom. So the first member was CH3, methyl. Okay, because each carbon substance, each organic compound should have at least 1 carbon atom. So that R represented there was alkyl group. But if we talk about aldehydes and carboxylic acid, these functional groups itself have their own carbon atom. Then this R can start from, it may start from, or the first member will have R as hydrogen to complete the single valency left on this functional group. Okay. Once again, when we talk about aldehydes, the functional group is CHO. For alcohols, we have run OH. The same way for aldehydes, the group is CHO. One atom of carbon, one of hydrogen, and one of oxygen. As we know, oxygen has double bond always because it has 6 electrons. It will complete with the help of double bond. It's octet. So carbon, double bond O, single bond H. Out of 4 valencies of carbon, 3 are being satisfied, 1 is still left. This is being done with the help of alkyl group, or because the functional group itself has got this carbon atom, so it can start with H also. The first member of aldehyde is, yeah, the naming is same. When we are going to remove E, and here because it is aldehyde, Al becomes the suffix. The naming will be Al. The suffix will be Al here. Okay, so the first member of this group of aldehyde, because meth specifies 1 carbon atom, Al will end with to tell the substance has a functional group which is called as aldehyde group. The functional group is CHO, C double bond O, single bond H, and because it has got 1 carbon atom, the name will be methanol. If it has got 2 carbon atom, ethanol, 3 propanol, 4 butanol, 5 pentanol. First methanol, second ethanol, 3 propanol, 4 butanol, and 5 pentanol. So you're going to write all the names and the structure and their branch structure in coming 2 minutes. Everyone will draw, everyone is going to write. Am I clear? In between, if anyone has a question, please ask me. Draw the structures on your children. When you are drawing that structure, then only you get to know that sometimes you make carbon as more than 4 valencies are being satisfied. Sometimes less than 4 are being satisfied. It should be always exactly 4. That is the valency that carbon is having tetravalent. Yes, Harsh?
Ma'am, I had a network issue. Can you explain methanol, ethanol again?
Yes. Okay. Ari, you also have the same question?
No, ma'am. I wanted to ask, do we have to learn the common names also?
Common names for first 2-3 elements, yeah. We have just first 6 types of functional groups, especially for formaldehyde, acetaldehyde is being asked also. The common names are being given and they ask you the structure. So formaldehyde, acetaldehyde, yes, you have to know this. First members definitely.
Okay, ma'am. Thank you.
Harsh, when we name the substance as we have done for alcohols, child, the same way, this also will have carbon to carbon single bond always present. So as per the single bond, we are going to write the name. If it is 1 carbon atom, it is methane, right, child? In place of E, we are going to write Al. Like, because it is aldehyde group, suffix will be Al. Aldehyde first 2 letters are Al. For alcohols, we have taken last 2 letters as suffix. The same way for aldehydes, we are going to take first 2 letters of aldehydes, Al, to just write the name as suffix for the substance. So if it is 1 carbon atom, then it is called as methanol. If you are going to have 2 carbon atoms, it is called as ethanol, 3 propanol, 4 butanol, and 5 pentanol. Is it clear now?
Yes, ma'am.
Good. Draw it right now. Last 30 seconds left. All the 5 structures, their condensed formula as well as their branch structure. Branching means CHO. Children, you can see CHO is being given the same. In the branch structure, this to be kept in your mind. You cannot just write it as per your choice. This CHO also to be given C double bond O, single bond H. You cannot write CHO. This also is wrong. This is the condensed form. When we show all the carbon and hydrogen bonds being given, this is only the branch structure. This is being shown how to write it, but this also is wrong. If it is being asked for branch structure, this can be condensed structure. All of you have done? The last part we have to start with carboxylic acid. Any one boy, tell me that you have already done, then we can finish with the carboxylic acid today at least. So functional groups will be done.
Yes, ma'am, done.
Okay, very good. So we are going to talk about carboxylic acid, children. These all functional groups which I am talking about, we have done alkanes, alkenes, alkynes, we have done alcohols, we have right now done aldehydes, and we'll be doing right now carboxylic acid. These are the main functional group. These name suffix will be added to the root name. Okay, so now let's talk about carboxylic acid. As you can see here again, carboxylic acid is having the functional group COOH. The very first acetic acid when was being given in acid bases and salt CH3COOH. To learn COH, why can't we write C is C, C2H4O2? Isn't it? That was the first question that must have come to your brain. But that is the functional formula, functional group of any substance. We cannot mess with that. Okay, right? So this is the way when we write it. And the functional group of carboxylic acid or organic acids is COOH. And how is the representation? C double bond O, single bond O, C double bond O, single bond O, single bond H. And this H part is going to be relieved and this becomes the replaceable hydrogen ion. And that is why these are called as acids. Acids are the substances which provide H plus ions when they are being dissolved in water. So this H plus, this is going to leave this one place vacant for the bond, and this is going to form single minus charge, and this H plus charge is being formed, and this is going to make the substance acidic in nature. Okay, so that is why whatever is the acid, whether it is formic acid or acetic acid, we have one OH, COOH carboxylic group, and each part is going to have COO minus and H plus. It breaks like this. Okay, if it is having H, it becomes HCO and H plus. If it is CH3COH, it will form CH3, COO single minus and H plus. This is the way it is going to form or generate H plus ion. Because it forms H plus ion, these are called as acids. First thing. Second thing, when we talk about the structure, definitely you are going to show like this. This is the branch structure. The last two functional groups, that is aldehydes and carboxylic acids, they itself, in the functional group itself, we have carbon atom. So here R can be H also. Starting from that single bond which is being left on carbon atom, that can be satisfied by hydrogen because at least one carbon atom is there in the organic compound. It starts from methanoic acid. Now how to name it? The same way alkane E will be removed and we are going to add oic acid. Methanoic acid, ethanoic acid, propanoic acid. So you write the name of alkane because carbon to carbon, leaving this bond, if you see carbon to carbon, it will be always having single bond. Single bond is alkane. So first we write the name of alkane, remove E, and in place of E, we are going to write for carboxylic acid. If I see that arrangement is COOH, it identifies the substance as acid. What type of acid? Organic acid. Technically, carboxylic acid. And because of that, it will be named as E will be removed and we are going to have oic acid, methanoic acid, ethanoic acid, propanoic acid, butanoic acid, pentanoic acid. Am I clear? Write the names, write the structures, and if you have any question, you can ask me. Anyone? Any of the organic compound, whenever we are talking about organic compounds, children, whenever there is a presence of COH bond, that is a functional group present, it is being identified as carboxylic acid. Why acid? Because COH is going to break to CO minus and H plus. This H plus is going to act as that is identification of acids. Substances that provide H plus ions or proton are called as acids. So H plus ions are being provided by COH functional group. So these all are acids, carboxylic acids, and the name will be, because carbon to carbon single bond, alkane, removing E. Same method, whether it is alcohol or it is aldehyde or a carboxylic acid. We write the name of alkane as per the number of carbon atoms, that becomes a root name. And then if E is being removed, it was alcohol, OL was a suffix. It was aldehyde, AL was a suffix. If it is carboxylic acid, remove E and write oic acid, like methanoic acid, ethanoic acid, propanoic acid, butanoic acid, and pentanoic acid. Right, children? I hope you all understood this part. Abhishek, did you understand this part, child? Anyone? Any question? Okay, so children, it is already 10:46. I'm going to end the class here. If you have any question, you can ask me. First 5 members of all the functional groups are important. This is going to be the root name or the main name of any organic compound. In the next class, we'll have in first 10 minutes, now you know how to name it. It is much easier. Next time when, yes, Sunny, I'll take your question. Give me just 1 minute. So next time when we are going to talk about substances, or we are going to talk about these compounds, what you're going to do is, this is the major name being given. Now after this, we are going to have the structures when we have arrangement of the compounds, like when we have some prefix, which are not that valuable, which are not that important, but we are going to take into consideration how to specify if we have alkyl group, or when we have our own halogens which are being present to remove, or we are going to replace hydrogen in the compound. Okay, so that names are being given before the root name. That we'll do it next time. Okay. I can see Sana has raised the hand. Sana, you can please ask the question, child.
Ma'am, in butanoic acid,
Hmm.
ma'am, can the COOH be on the second or third carbon?
Yes, one very important. This carboxylic acid is being given the maximum value. Maximum means this will be always on the terminal position. This can never be on the sides or the second or third part. It will be always a terminal position where we can find the carboxylic group or acid group or COH. That is the last terminal position where we'll have. It is not possible to have this group at any other place.
Okay, ma'am. Thank you.
Any other thing anyone has to ask? Yes, Naman, please ask.
Ma'am, how to remember the condensed formula of like ethanoic acid and propanoic acid, ma'am? Means it is CH3 dash CH2, like that, ma'am. COOH.
No, you don't have to learn that way. Which part you want to know about alcohols?
Ma'am,
Which part?
carbolics.
Carboxylic acid?
Yes, ma'am.
Okay, then you have to learn just one thing. CnH2nO2. Because COH is there, no? So what you learn? CnH2nO2. The number of carbon atoms, if you compare, double will be for hydrogen, and there will be 2 atoms of oxygen being present in that same. It is CnH2nO2 for the condensed formula.
Ma'am, for carboxyl?
Carboxylic acid, yes, child.
Yes,
Because carboxylic group is COOH. So double O is there every time. So the formula will be CnH2nO2. Okay, what, Naman, you're not able to understand, no? Get the value for n is equals to 1. CnH2n. So H will be 2 and O2. So HCOOH. Right? Did you get it?
Yes, ma'am.
Understood this part? If it's still you're not able to understand, when I'm going to have the next class, just remind me, I'll give you the condensed formulas for all the substances, all the functional groups. So it will be much easier. You can make a table out of it, or make a table and represent in the first of the slide, so that it will be much easier for you to write it. Okay, children? Any other question? Okay. Good morning and thank you, teachers, and good morning and thank you, children. Do not forget at 11:45 sharp, you will be given the link. Link will be posted. You have to use this and you have to take part in your inter-house quiz. All the very best. Take care.